Hello, so what we're going to do today is we're going to talk about distribution and combining like terms. So to keep this video from being like 45 minutes long, I'm going to kind of skip around in this a little bit. So we're going to do quite a few of these examples, but not every single one together. So first up, the distributive property is when we are clearing parentheses using multiplication. Right? You've probably run into the distributive property before, right? So when I'm trying to take a look at something like this and simplifying this using the distributive property, I'm saying that I have 5 times all this stuff in parentheses. So our shortcut way to kind of move through this is to imagine, 5 times that x to start things off. So 5 times x is really just 5x. After that, I'm then also taking a look at what 5 times 2 is, right? And 5 times 2 is 10, right? Because it was a positive 10, I'm going to leave that as a plus sign there, right? And that's really all there is to it, right? We're distributing that number throughout the other pieces, right? We're using multiplication to do that. For the second one here, right, I have 4 times 3 x's. So the 4 and the 3 combined together, right? 4 times 3 is going to give us 12, and that x is along for the ride. All right, after that, we've got 4 times 5. So 4 times 5 will be 20, and again, it's positive 20, so I'll put a plus sign there. Right. That's really all there is to it. You've probably run into distributive property in the past. There's not really much else that's fancy along with it now. Then you work on some where you have some negatives involved, right? And where the negative is depends on how you're going to handle it. For ones like number 3 here, you got negative 7 times 2x. So if you have negative 7 times positive 2, that's going to be negative 14. And again, that x is still included. We didn't have to change it, right? We didn't multiply it by anything itself, but it is still included with that 2x piece. As for negative 7 times 3, right? Negative 7 times 3 is going to be negative 21, right? And again, because it's negative 21, I'm going to put it down with that minus sign there. All right. The next one down is, again, a little tiny bit different. There is a negative involved, but it depends really on where it is. Right, so on this one, we've got 8 times x, right? And this is regular old 8 times regular old x. It's going to be 8x. Then we move on, we've got 8 times negative 4. So 8 times negative 4 is going to be negative 32, right? So, hopefully that seems pretty all right so far. I'm going to skip over 5 because, again, I don't want this video to be 8 hours long. Right, we're going to skip down to 6 here. If I've got something with a negative on the outside, and then you'll notice a little further in, I've got that negative on the inside, we'll just kind of talk through that real quick. So on this one, I've got negative 6 times positive 4x. So negative 6 times positive 4 is negative 24, and again, that x comes along with us. The second piece here is negative 6 times negative 5 in the blue. So negative 6 times negative 5 is positive 30. So because it's positive, that's now plus 30 there. Right? So it's really important to pay attention to what things you're multiplying, and that'll kind of help you figure out what signs you're supposed to have. Something that's helpful is that when you're considering that negative 5 in the parentheses, don't just look at it as times 5. Think about it as times negative 5. Right? Grab that symbol that comes in front of it, whether it be a plus or a minus. All right? When you get to ones that are a little bit longer, there's not really much that changes, right? We're just doing more, right? So let's take a look at this first one. We have 9 times 5x squared, right? So the 9 and the 5 multiply, and 9 times 5 is 45. And again, that x squared comes along just like the other times with the x's. Next up, we've got 9 times, again, negative 8, grabbing that symbol in front of it. So 9 times negative 8 is negative 72, and an x on there. And then last but not least, we got 9 times 7, right? And it's a positive 7, right? So we don't have to worry about any negative stuff at all. 9 times 7 is 63, right? And that's really all we're doing, right? Again, I'm going to skip over 8 in the interest of time. We're going to talk about stuff like 9 and 10 where things start to look a little bit worse. So even though they look worse, that doesn't mean they are worse. All right, so let's take a look. If I'm looking at this very first arrow of number 9, 3x times 6x, right? The 3 and the 6 go together just like we've been doing, right? So 3 times 6 is 18. When I'm looking at x times x, right? We've talked a little bit about, x times x, right? In the past, we've talked about how, when you have something like x squared, or actually not even x, if we had something like 4 squared, what that really means is it's 4 times 4, right? So whenever you multiply something by itself, it turns into that thing squared with that second power on it, right? So when I do x times x here, I'm going to end up with x squared, right? And that's going to work out that way. Anytime you've got something multiplying by itself, you got to think about how many you had and how many you're multiplying with and count them all up, right? So 1x times another 1x gives you x to the second power. After that, we've got 3x times 8. 3 times 8 is 24. It's a positive 24. And then again, that x still comes along. There wasn't anything for that x to multiply with this time, but it still counts as part of what we're multiplying with, right? What I'd like you to do, actually, let's talk through this one. I was going to say, try this one on your own, but I mean, if you want to, if you're feeling confident, go for it. But this one might be a little tricky as well. All right, so let's take a look. First thing here is we've got 8 times 3, right? It's going to give us 24. And then we got to worry about the variables. So there's an x on the outside with the 8. There's an x on the inside with the 3. Those are going to give me x squared, just like on the last one. And then that y comes along as well, right? That's included. And that's the only real difference is that, you got to match up the variables with which ones you're multiplying with, right? Up next in the middle, we've got 8 times 5, which is 40. And then again, no x's or y's in the middle of there, but we still have to bring one of each along because that's what we started with. What I'd like you to do is try figuring out this last one, that black arrow there, 8xy times negative 2y. So hopefully you gave it a shot. If not, pause and, do that real quick. Right? But what we're going to get is 8 times negative 2 is negative 16. The x comes along because there's no other x's to multiply with. And then the y's this time, right? We have y times another y. We're going to get y squared there, right? And that's what we're trying to get to, is something like that. All right. We'll go through a couple more of these. I'm actually going to skip down to number 12 because it's pretty similar to 11. And again, trying to value your time. So for number 12, first things first, right? Negative 3 times negative 2 is positive 6 with those numbers there. When I'm looking at the x's, right, this is where things get a little on the tricky side sometimes. I've got x to the third on the outside and x squared on the inside, right? So you might be thinking like, oh yeah, that's going to be x to the 6th. But that's not entirely right, right? What we've got to think about is on the outside, I've got 3 x's all multiplying, right? X to the third. On the inside, I've got x squared, which is 2 x's. So all together, however many x's I have multiplying, that's going to be my exponent. So in this case, I've got 3 on the outside times 2 more on the inside. That's 5 x's total. So that's where we're going to get that 5th power from there, all right? We're going to be doing the same thing, more or less, on this middle piece, right? We've got negative 3 times the 5, right? So the numbers multiply first. We're going to get negative 15. And then we've got x to the third times another x. So again, there's 3 x's out on the left side there. There's 1 on the inside. Altogether, that means that I am multiplying together 4 x's. So it's going to be x to the 4th. All right. And then last but not least, hopefully this last part is something that doesn't seem so bad. Right? We've got negative 3x to the third times negative 9. Negative 3 times negative 9 is positive 27. And then just like usual, those x to the thirds come along with us, right? We got a little tiny bit left to talk about with distributive property, and then we'll take a look at some combining like terms real quick. So if I wanted to simplify something that looks like this, right, you might notice that there's just a minus sign on the outside. There's no actual, there's no number to distribute. So what I'm going to tell you is that when you've got just a negative sign on the outside, there's really a little invisible 1 on the outside of there, right? So we're going to use that to multiply with. And then it's just, running as normal. Negative 1 times 7 is negative 7 with an x along with it. You do negative 1 times positive 9, which is going to be negative 9. And that's it, right? The shortcut kind of way that you can think about it is you'll notice that I started with a positive 7x on the inside, right? Let me There we go. I started with a positive 7x, and then when I did this out, I ended up with a negative 7x. This was a plus 9, and now it's a minus 9, right? So you can think about it just kind of like flipping all the symbols to their opposites, right? What I would suggest is when you're still like practicing with these, do it out with the little invisible 1 there, right? We're going to fill that in for this one. I'd actually like you to like pause here, try that one out, and see what you get. So, whether you use the shortcut or whether you did it out like I'm going to show, you're going to get negative 4x from that first arrow, and then you're going to get plus 6 from the second one, right? Because negative 1 times negative 6, right? So hopefully some of that was review for distributive property. Hopefully it's, helping out, reminding a little bit. We still have to talk a little bit about like terms, right? So what is a term? Right? It's one of those chunks of an expressions made up of numbers and variables. All right, so you could have, 3x, you could just have 3, you could just have x, right? It can be some combination of numbers and variables, and that's what makes a term, right? On these last ones, and I don't mean to, go back and forth on pages and stuff. On that last problem we just did, the 2 chunks, right? Negative 4x is a chunk. 6 is a chunk, right? Each one of those is made up of numbers and variables, right? Those are 2 different terms that we've got. Right? When we're talking about like terms specifically, we're going to be a little bit pickier, right? These need to be terms with the same variables and exponents. Right? When we're saying exponents, they need to be on those same variables. So they really need to match up. It needs to be like a mirror image of the other term in order for them to be like terms, right? And last but not least, we're going to kind of review what a coefficient is, right? It's just a number that's in front of a variable, right? So when I have something like 7x, that's telling me that I have 7 x's there, right? So we'll go through a couple examples of like terms and unlike terms. So you might have something like 6x and 8x, right? Those are like terms. They have the same variable, x, right? And the same exponents in a way, right? They don't really have exponents. There's really actually a little hidden 1 on each one of those x's, right? But we're not super worried about those, right? As it looks, they have the same exact variable and the same lack of exponents. Something similar that would be unlike terms is if you had 6x and 8y, right? They don't even have the same variables to them, right? So you cannot combine them, right? That's what we're going to try and do with these like terms, is we're going to try and smush them together. You might also have something like terms, say they had like negative 7xy squared, right? And then let's say that your other one was 13xy squared, right? So the negative 7 and the 13 don't need to match, right? Like that's no big deal. Those are just coefficients. But the variables match, right? They both have x and y. And then they both have a second power, right? That squared part on the y's, right? That's what makes them like terms, is that they really do match up. If I had something like, 4x squared and negative 10x to the third, those would not match up, right? They both have x, but they don't have the same exponents on those x's, right? One has a squared, one has a third power, right? So those are not like terms. Right. Last little example we're going to talk through. If I had 18x squared y to the third and say something like 21x squared y to the third, right? Again, those are like terms, right? They have the same exact variables, x and y. The x has a 2 on it, the y has a 3 on it. We're all good to go. They're like terms. However, and this is the one where people kind of mix things up sometimes, so we're going to have 15x squared y to the fourth. Say something like that. And then let's say that our other term was 11x to the fourth, y to the second. So a lot of people will take a look at that and say like, oh yeah, it's got the same variables, x and y. It's got the same exponents, 2 and 4, right? They both show up on each one. But those are not like terms, right? The reason why is that they have to match up perfectly. The fact that this is x squared and this is x to the fourth, that's an issue. Right? The fact that this is y to the fourth and that this is y squared, right? Those don't match up together, right? You need them to match up perfectly for them to be like terms, right? So what I'd like you to do is pause here, right? Work through 15, see if they're like terms or not. See if they have the same exact variables and exponents on those variables. So if you gave it a go, right? These are like terms there. These are not. Nope. Yes and nope. Right? So the ones that were yes, right, they all have the same variables with the same exponents on them. Right? For the ones that are not, right, like if I'm looking at B, that first part has a squared on that X. Right? So that one's not matching up with the one that doesn't have a squared there. This one, the X doesn't have a squared, but it does later on, right? And then this one down here is the thing that we were just kind of finishing off talking about, right? The X has a 4 and the Y has a 2, but then they flip-flop, right? That makes them not like terms there. Right, so when we're combining like terms, it might seem a little spooky, right? There's a lot going on in these problems when you write them out, but what we're really doing is we're just adding together the things that go together. So what I'm going to do here is I'm just going to start by looking for what my like terms are. If I'm looking at 10, I'm trying to think of myself, all right, what else goes with 10? 10 goes with 10, right? Those are like terms. And then also taking a look and saying like, all right, can I match up anything else? We've got positive 3x and then another plus x there, right? Those would be like terms as well. So group them by the like terms, and then we're just going to smush them together based on what the signs say. So you might notice that on mine, I didn't just underline the 10, I also underlined the plus sign that was in front of it, right? So just like when we're doing distributive property, we want to grab the symbol that comes in front of it, right? I also did that with this 3x and also this regular x, right? I grabbed that plus sign in front of it so I know what I'm supposed to do. So when I go through this problem, right, I'm going to start by just combining the like terms. 10 plus 10 is 20. Right? That's really all there is to that one. When I'm taking a look at the x's, I had 3 x's plus another x, right? So you can think about it as like, oh, now I have a 4th x that I'm adding on, right? So that's what we're going to have, plus 4 x's, right? I know it's really tempting to say like, oh yeah, 3x plus x, right? You really want to say like, oh yeah, this is going to be 3x squared, right? But again, we can't do that. The only time that we turn something into a squared is when we're multiplying, right? So if instead of addition, that was multiplication there, then we could get 3x squared, right? But when you're adding them together, all you're doing is you're changing that coefficient. We're changing how many of them we have out in front. Excuse me. So what I'd like you to do is take a look at this one, right? We're going to kind of grab the like terms together, and I'd like you to smush them together, right? So I've got negative 6x that can go together with the other x. They're both x's. They're like terms. Same thing with 8 and negative 14. All right, so when I'm taking a look at the stuff I have underlined in red, those x's, if I had negative 6x's and then I added 1 on, I'm going to bring myself up to negative 5x's. Right? As for the numbers 8 and negative 14, just think about what's 8 minus 14. Right? And that's going to be negative 6. And that's really all I'm trying to do. Is I'm just matching them up, smushing them together based on how they look. Right? So, again, I know I'm kind of, excuse me, kind of talking for a while. What we're actually going to do is we're going to skip ahead a little bit. We're going to skip over 18 and 19. We'll talk about a couple of these ones at the end. So for number 20, we want to simplify using distributive property and then combine the like terms that we still have left over. So first up, I'm just going to start by distributing, right? I'm going to take a look at just that first set of parentheses. So when I have 9 times x, it's just 9x. When I have 9 times negative 2, that's negative 18. Right? And that's as far as I go with that 9. It's distributed to its own set of parentheses, and that's where I kind of have to stop with that one. Right? If you hear any clinking and clanging in the background, that's the cat running up and down the stairs. I'm sorry about that. All right, after that, we've got this plus 5 that's going to distribute into that second set of parentheses. So 5 times 5 is 25, and then that x comes along. Same thing with 5 and 7. 5 times 7 is 35. Okay, so from here, we now have some like terms, right? I'm going to underline them different numbers or different ways just so it stands out from the other colors, right? If you have a way that works best for you to kind of group them together, that's fine. I've seen people in the past, and if you're looking for, an idea, I've seen people like, oh yeah, put some of them in boxes and then like circle the other ones, right, to group them up, right? Whatever works for you. So on here, this 9x and this 25x are like terms, right? They both have x's. This negative 18 and this positive 35, those are also like terms, right? They're just numbers. So when I've got those x's, 9x plus 25 more x's, it's going to bring me to 34 x's. Right? Again, we're changing that coefficient out in front. As far as negative 18 plus 35, if I plug that in a calculator, it's going to spit me out to positive 17, right? So that 34x is what we got from the underlined stuff, and the 17 is what we got from the squiggles. Right? So these problems can look pretty scary, right? But when you do them just one thing at a time, that's really the trick to a lot of math, is just do it one thing at a time. Don't worry about jumping to an answer. Do one thing and then do the next thing and keep moving your way forward. So what I'd like you to do is try out 21. It's pretty similar to what we just did. So if you haven't paused and tried it out yet, give it a go, right? I'm going to run through it real quick because, again, I feel like I'm talking for a long time. So first set of distributions, 6 times x is 6x. 6 times 3 is 18. Then we've got this negative 8 in there, right? So again, remember that we want to grab that symbol that comes in front of things. So when we multiply by negative 8, that's going to make a difference. This is now going to be negative 24x's and positive 32, right? If you missed that negative 8, right, that's okay. It shouldn't be that big of a fix to make, right? You just change some signs around. It might change what you got from combining, but it's really not a big deal to fix, right? And that's all right. So when I'm looking for like terms, we've got these ones with x's. I've got these regular old numbers, and then we're just going to combine them together. If I had 6 x's minus 24 x's, it's going to bring me down to negative 18 x's. 18 plus 32 with the squiggles underneath them, when I smush them together, they're going to give me 50. Right? And that's all I'm really getting to. Right? We're going to talk through one last little bit. Right? So I'm actually going to skip ahead to the last one, 23. Right? So we are skipping over 22. If you would like to try it, I will, finish it up before I post the notes, just like with all the ones we skipped over. So if you wanted to try any of those out on your own and check your work afterwards, perfectly fine. Not a bad idea at all. But 23. Let's work through one thing at a time. Right? So this first set of parentheses here with the negative 3, I'm going to start by just distributing. Right? That's what they want us to do. So negative 3 times positive 4 is negative 12. And then that x squared comes along. Now we've got negative 3 times a negative 6, which is positive 18. And again, we bring along the x. Now we've got negative 3 times positive 5. It's going to be negative 15. Right? So again, nothing super fancy that I've done so far, right? We're just distributing, right? That's what we were working on at the start. After that, we then have to distribute this negative 2x into the second set of parentheses, right? So again, one thing at a time. Negative 2 times that positive 9 that's in there with the blue, it's going to give us negative 18. And then we have an x times another x, right? And again, when we're multiplying x's, that's when we change the exponents. That is going to be x squared there. After that, we got negative 2x times positive 4. So negative 2 times positive 4 is negative 8, and that x comes along as well. All right, so then we start looking at like terms. All right, I've got these ones with x squared. I've got these ones with regular old x's. And you might notice that this minus 15 was just kind of left out on its own, right? Sometimes this happens. Sometimes you won't have something that's like terms with the other stuff, right? So let's kind of run through the other stuff, and then we'll talk about what to do with that negative 15. So if I'm looking at the stuff with x squared, right, the stuff that's single underlined, if I had negative 12x squareds, and then I'm subtracting 18 more x squareds, I'm going to get to negative 30 x squareds. Right? If I'm taking a look at the stuff with the squiggles underneath it, 18x's minus 8x's It's going to leave me with 10 x's. And then that negative 15, right? So it is fine that it doesn't have something to combine with. That's going to happen quite a bit. All we need to do is just bring it right down. Negative 15, all right, cool, negative 15. And that's all we're looking for, right? So I'm going to wrap it up here for now. Like I said, I am going to go back through and do out all the problems that I skipped over, right? So if you wanted to see what the answer for 22 was, feel free to check on that Google Classroom folder with all our notes in it, right? If you wanted to check your work. As for now, I'm going to leave it there. Please be sure to ask questions if you've got any, and I will see you later.